Welcome to the Battery Testing Mentor podcast. My name is Johannes and here I discuss all topics around battery testing, battery safety, battery handling. Short, on the point and with practical advice. Also visit www.batterytestingmentor.com and sign up for the email update. With every episode I send out a short summary of what I was talking about so that you know if you want to dive into more detail. If you have any questions, any advice, any feedback, reach out to me. You can just hit reply on that email and you directly reach me. I'm still here starting to restart, basically. I'm trying to get everything set up here in the new apartment, so it's still a little bit, messy. I mean, the good thing is you don't see what's behind here, the camera. I tried to record today at night in the evening. So yeah, the quality is not yet there where I want it to be, but I would say we focus on the content today and step by step it gets better here. I brought today the topic of battery safety testing. Battery safety testing, there are several points. One is that I did battery safety testing myself when I was young, when I was just starting my work life. Battery safety testing is an extremely important area of testing as you really want to have your battery in your application safe. You don't want to sit in a car where the battery regularly starts burning. You don't want to have a cell phone where the battery starts burning. You want batteries to work really reliably and in a safe way. And if something goes wrong, then ideally the battery shuts down and doesn't go into thermal runaway. The other point why safety testing of batteries is so important, I think I talked already about this once, is that you have the energy conversion, the energy storage in one point. In the battery, you can't separate it like if you have a combustion engine vehicle, you have the tank in the back of the car, the engine in the front. If something goes wrong in the engine where the fire is happening, basically the burning of the petrol, you can just shut off the petrol line. There's no more petrol coming in. Yeah, basically it burns out and everything is safe. On batteries, that is impossible because everything is inside the battery. It's one chemical plant. You can't separate storage and conversion. So safety is important and will always be important. And the last point why I wanted to talk about this today is also because recently I was involved in a project again where we dove into this battery safety testing, what you need to when you set up your battery safety lab. And I thought it's definitely worth talking about because there were many questions coming up. So if you start now at the basics, there's battery safety testing. The first question is it different to battery abuse testing, which is also sometimes used as a name? In short, it's not. Both is the same thing for testing outside the operational conditions. If you remember this matrix that I created here once, everything that is testing outside the operational conditions where you want to go into thermal runaway, where you want to try out what happens if the battery is abused, is used not in the right way, then you call it battery safety testing, battery abuse testing. Abuse has a little bit negative connotation because of the use of abuse in different settings. Therefore, kind of to make it a little bit more positive, this term battery safety testing is used. But basically, it's to show the safety of the battery by trying to put it outside of the operational conditions. Nevertheless, in the end, it's exactly the same. Okay, so you want to test your battery for the safety aspects. What do? You take the battery and you do the test first, right? To make it kind of not so dangerous for yourself, you can, of course, go outside. You go on the parking lot and connect the battery to an power supply and overcharge it. And then basically you could do your battery safety testing, your overcharge testing. But that is, of course, very, very simple. Also environmentally not recommendable. You should really improve then your setups. And for the setups, there are a lot of different influences that need to be considered. If you think about this example on the parking lot, what do you want to make sure? You want to make sure that it operates in proper environmental conditions. In winter, it's too cold. In summer, it's too hot. If it's raining, it doesn't work, right? You need some area where you can control the environment. You can protect the battery and make the test repeatable so that you really can repeat the same test different times and get the same result. So you could put it in a climate chamber, but due to the potential reaction of a cell, I mean, if you overcharge it now and it just shuts down, it's great, nothing happens, then you can do it in a climate chamber. But there is always a risk that the battery starts burning, going into thermal runaway. You have the worst possible reactions like this explosion according to the hazard levels. Your chamber is damaged and it will be a very expensive test. So you need to make it a little bit more solid. You need to build a room that can withstand such a fire, such an explosion. And basically you can start there with containers that are pretty enforced and solid and can withstand such an event. And then at one point you need to go into like building bunkers made out of concrete to handle this energy that is released. Even containers, they are very simple solution, but they have very soon a kind of problem. They can't handle all the energy and might be damaged as well. That is not something that is a remote possibility, but it's a very, very likely possibility. Then you have the test room. You need, of course, some to have it closed, because if a battery reacts, you don't want that this smoke, the hazardous materials we talked about, this kind of all the electrolyte contents go out and affect you as operator or as one who witnesses a test. So it must be closed and sealed off. On the other hand, you need holes because you want to bring your cables in your measurement devices and you don't want to put the cycler inside this room and then be exposed to the smoke, to the fire. But really make sure that you have this disconnection, but at the same time the connection through holes, and they must be sealed so that you're really protected from what is happening inside. And then we encountered the other problem that if you have the room and it's completely sealed and you have a big fire or also a very fast increase of the volume, like you could call it explosion, it's in the worst case in batteries officially a deflagration, you have a pressure build up, and if you have then a closed room, you have a huge other problem. Because pressure is a very, very strong force and it will just find a way out and will probably destroy some walls or move some walls, doors, windows, and so on. So you need to make openings so that the pressure can go out. That's then basically, now we have a nice environment. Is this enough? You can basically put your battery in, your cables, the cycler, you overcharge, everything burns, nice. Test is done, but the next point comes now, where does the smoke go? If you just have your room and some pressure reliefs, then at one point the smoke will just steam out of the room. You will have a huge cloud of dirty smoke, hazardous smoke that we want to avoid. So we need to adjust some additional machines to clean the gas to make sure that you test environmentally friendly. But then you're sucking out all the air, you need to take care of air inlet. And then again, you come into second and third order effects where you need to say, okay, where does the air come from? How do you prepare the air and so on? So you need to prepare or consider a complete air handling system from the exhaust gas cleaning to the air inlet and heating, cooling. And this, you could then also do the test, but even then you will reach at one point an issue when you test too big of batteries and you can't handle it anymore. And if there's really a big battery starting to burn, you need to be able to stop it. It is something that is very, very hard. Like, just if you haven't seen a battery fire in kind of real life during such a test, then just Google these fires of battery car fires, electric vehicle fires. That is a massive fire if this starts to burn, and it's not easy to extinguish it. Nevertheless, you need to take care that in such an facility, you have also this whole fire extinguishing systems inside. And yeah, then the next tricky point is, of course, that this whole setup needs to be designed so that you can test repeatedly over and over and over again. If you design it for like that it extinguishes the fire once every 5 years, you very likely will run into a point where you just damage all the stuff and you can't operate it at all anymore. And you have then kind of do huge refurbishment. So you need to consider this from the beginning. Another very important thing is now we talk about the cycler and doing the overcharge test, putting the cables in, is that you can't kind of try out this test. If you go into abuse testing, if you press start and you get outside the battery operation conditions, there is no way back. Everything must be set up that you can do it in one go, in one repetition, or there's no repetition. There is no way of saying, oh, I forgot this camera. I need to go in to this room and set up the camera or change the angle from the camera. Everything really must be set up in a way that you have it ready if you say that you press the start button. This is really a super important thing because in performance testing, in environmental testing, it's super easy to say, okay, let's do a trial run. Let's do a first cycle and see if the plugs are working well and so on. If you say you do an overcharge test, you can't say, let's do one kind of dry run overcharge test. I mean, you can pretend to have one, but there is no way to say, let's do an overcharge test and then do the real overcharge test later on, unless you get 2 batteries. Yeah, and this all need to be considered. There is a lot more to think about in the setups, from how to operate, how to protect people from this dust, from this hazardous stuff in the air, to how to move the batteries in and out, how to make this efficient. It's really a big thing, not easy, and yeah, not too many points to talk about in 15 minutes. And as the time is running out, I hope I gave you just some glimpses of what is necessary there. If you want to know more, just let me know, reach out to me. Happy to talk about this in more detail. For this week, I leave it at this point. I thank you for your attention and look forward to hearing you next time again.